This lecture is on explosions. In an explosion, one object breaks apart into two or more pieces, or coupled objects break apart, moving afterwards as separate objects. So for instance, an example of this would be a plate that falls and breaks into many pieces and scatters in different directions, a rocket exploding. We could have somebody jumping off of a skateboard. All of those are examples of explosions. To make the problem solvable at this math level, we will make the following assumptions. The object, or a coupled pair of objects, breaks into two pieces. The explosion is along the same line as the initial velocity. So we're not going to worry too much about two-dimensional problems right now. Here's a schematic of an explosion. Can you see how it's time reverse picture of a perfectly inelastic collision? So here we start with two objects and stuck together, and here we end up with two separate objects. So let's go ahead and write in our vector signs because the momentum is a vector quantity. So here both A and B have the same initial velocity. After the collision, notice that we have the momenta of particle A and the momenta of particle B, and they have two different velocities. So this tells us that the momenta we start with of both A and B has to equal the momenta we end with for A and B. And so we can say that the total mass times the initial velocity of both A and B together is equal to the mass times the velocity of particle A after the collision or after the explosion, plus the mass times velocity of particle B after the explosion. So let's go ahead and do an example. A 5-kilogram cannonball is loaded into a 300-kilogram cannon. When the cannon is fired, it recoils at 5 meters per second. What is the cannonball's velocity after the explosion? Okay, well first we have to pick a direction of motion for this. So I'm just going to assume that I'm initially going east, and that's my I hat direction. And that means that this recoil is going to be minus 5 meters per second J hat, or I hat, sorry. So go ahead and pause the video and see if you can solve this on your own. Okay, so let's see if you have the right answer. We're going to go ahead and pull this out. We start out with an initial mass of 5 kilograms for the cannonball, 300 kilograms for the cannon. The initial velocity of the cannonball and the cannon are all 0 meters per second, and we're going to make that I hat. The recoil is going to be negative 5 meters per second I hat. Okay, so we start out with m1 plus m2 times the initial velocity, and that's got to equal m1 v1 prime plus m2 v2 prime. Now we know that the initial velocity, it's given, and it's 0 right here. So what we're going to do is that ends up giving us m1 v1 prime plus m2 v2 prime equals 0. And that means that m1 v1 prime is equal to negative m2 v2 prime. So solving for v1 prime, we have negative m2 v2 prime over m1, and this is negative I hat. And that means that the cannon is going to move at 300 meters per second. The cannonball is going to move east at 300 meters per second because the cannon went backwards 5 meters per second. Okay, so let's go through this again. We have M1 is the cannonball, M2 is the cannon. They're both connected. The cannonball is inside the cannon. The recoil of the cannon is negative 5 meters per second I hat. Solving algebraically and substituting in our numbers, notice here there's a negative here. Negative here, we have a negative here. Negative times a negative gives us a positive. So it's 300 meters per second I hat is the velocity of the cannonball after it's launched. Okay, two rail cars, one with a mass of 4,000 kilograms and the other with a mass of 6,000 kilograms, are at rest and stuck together. To separate them, a small explosion is set off between them. The 4,000 kilogram car is measured traveling at 6 meters per second. How fast is the 6,000 kilogram car going? Here, let's assume that the 4,000 kilogram car is moving at 6 meters per second I hat. Go ahead and pause the video and see if you can solve this one. Okay, so let's see if you have the correct answer. We know the mass of car 1 is 6,000 kilograms. The mass of car 2 is 4,000 kilograms. We know that they start at rest. So we know that V1 equals V2 equals V, which equals 0 meters per second. I hat. We know that the second car, the 4,000 kilogram car, travels off at 6 meters per second I hat. So we know that the sum of the masses times the initial velocity is equal to the m1 v1 prime plus m2 v2 prime. That means that 0 is equal to m1 prime m2 prime. Solving for one over the other, we end up with v1 prime is equal to negative v2 prime m1 over m1. Since this is I hat, then that means that the 6,000 kilogram car is going to move negative 4 meters per second I hat. Notice that if you forget to do the negative here, right here, if you forget this negative right here, you're going to end up with a positive answer, and that's going to be wrong. Both of these cars are moving away from one another because they're initially at rest. And that means the other car has to be moving in the opposite direction for that to happen. Remember, momentum is conserved. Okay, that is the end of this lecture on explosions.